Hello everyone. Alright, so here's our next lesson. It's going to be on something called percent yield, but let's review just a little bit, see where we're at. Okay, so the last thing you did was learning about limiting reactants. Oops, let me change that so it doesn't keep going out of focus. I keep forgetting to do this before. Sorry guys. Okay, all right, so we learned about limiting reactant problems. This is where you know the amount of each of the reactants, and your experiment is you're going to mix them together and you're going to figure out how much product you can make. Well, in order to figure out how much product you're going to make, you've got to know which one of these is going to run out, because at that point, that's where the reaction stops, and that's going to limit how much product you have. So what you should have done in your problems is figure out which one of they're going to both be minuses, right? Which one of these are you going, which one of these values here, which we changed into moles, is going to be that actually runs out. And if you get the right one, then you're going to have leftover of the other one. Okay, if you didn't do both, okay, some of you I saw on what you turned in, you only did one of them. You have to do both to show which one is the limiting reactant. Okay, you have to figure out how much of each one you're using up. Okay, if I put in minus 1.03 over here, used up all of this, what you would have found is this amount would have been greater than what you actually had. So then you know that would be impossible, and you'd have to switch and use the other reactant as your limiting reactant. Okay, so that's how limiting reactant problems work. Limiting practice 1, all you had to do is figure out which one of these was a limiting reactant. You didn't have to do this part, sorry. I went all the way and I wasn't supposed to. Okay, and then for limiting reactant practice problems 2, this is where you actually figure out how much product you made. Okay, so you'd have to figure out which one's a limiting reactant, and then from that limiting reactant figure out all the other values using mole ratios, and then find your answer, change that into grams to get your final answer. Okay, so today our lesson is on something called percent yield. So if you were to actually do this in the lab, which we can't do our experiments because we're not in the classroom, but if you were, then you would be comparing how much you actually made, you yourself mixing it together, how much you actually made, you compare that to what you did, on paper. So this is in theory what you would have gotten as your product, and then you would do it in the lab and then see how much you actually really do get. Okay, so the point of percent yield is that your laboratory chemistry does not equal your worksheet chemistry. So what you do on paper is not really going to be what you get in real life, right? This kind of happens in all areas of life. What you plan isn't actually what happens. Okay, so so when the purpose of the lab is to make product, and in the business world, that's what it's all about, right? If you are making a product using a chemical reaction, that's the whole purpose of doing the chemistry. You want to make that stuff and sell it, maybe. Okay, so if that's what you want, then how you do the lab is important. Okay, so let's say you are making hand sanitizer. You're mixing chemicals to make hand sanitizer, and you want to make so much hand sanitizer. And you have your starting materials. You figured out on paper how much you need. Well, oftentimes you're not going to get that as your product because you lose things on the way. Okay, so how you do it, part of how you do it is your technique. So you want good technique. Okay, so you can get more reactants to go to products. More of your reactants to go to product. And you want maximum product recovery. So these are actually two different things. Maximum product recovery and separation. Okay, this is called purification. Okay, so you want all of your little reactant molecules to hit each other, rearrange, and then they can become product. So part of your technique is to make sure that all your reactants can meet each other, right? So that could happen by stirring. Like maybe you saw in your baking soda when you reacted the baking soda with the vinegar, it seemed like the reaction stopped, but then once you stirred it or swirled it around, then the reaction started happening again, right? That's because not all of the baking soda reached the vinegar. So you want to make sure that you get all your reactants as much as possible to collide with each other to rearrange and make product. Okay, and then the other thing you want to do, that's part of the good technique, is once you have your product, it's probably not going to be pure. It's going to be mixed in with your excess reactant, right? Or maybe the reaction produced two products and you only want one of them. So recovery and separation or purification of that desired product is going to be important. So your technique is going to matter there. Okay, and then the other thing, of course, is measurements. Okay, so if you say you're going to make 5 grams, well, that's, that could be anywhere from, 4.5 grams to 5.5 grams when you round it, right? So precision makes a difference. Okay, and then sometimes if you want precision, that means you're going to need to use better measuring equipment, right? So that could mean getting dollars, cost more money. Okay, so like I said before, what I mean by measurements and precision is 2 grams. When you write 2 grams like this, it doesn't mean the same as 2.00 grams. Okay, this one right here can mean anywhere, because it's rounded, it can mean anywhere from 1.5 grams all the way to 2.4 grams. And that can make a difference in how you determine your percent yield. Maybe you were supposed to make 2 grams, but it was this 2 grams and you only made 1.5 grams. Well, that's a big difference in that small amount. Okay, so the percent yield is going to help you determine how well you did in the lab. So how do you know how well you did in the lab? Okay, and that is, there's a number that you can calculate, and it's called a percent yield. Okay, and then this right here, this yield, this always means product, okay? So you're comparing product, the product that you figured out on paper compared to the product you actually made. Okay, so this is a measure of how close your lab results are to your stoichiometry calculations. Okay, sorry, I'm doing abbreviations there. Okay, stoichiometric calculations. Okay, and then your theoretical yield. Theoretical yield. Okay, this is your stoichiometry. Stoichiometry results. Okay, this is what you did on paper. And then you have your actual yield. Okay, what's yield again? Yield is product. So we're comparing product. Actual yield is your measured product from the lab. All right, now we're not going to be able to do stuff in the lab. And anyway, even if we were in class, I would give you worksheets along with the lab. And there would be percent yield problems. So just know that if you're doing a percent yield problem from a worksheet, they're always going to give you this, okay? So this actual yield is always given on a worksheet problem. Okay, now to find percent yield, here is the formula. Remember, it's a number. Okay, so this percent yield, the formula is, you're going to take your actual yield divided by your theoretical yield times 100, because it's a percent. Okay, that's going to give you your percent yield. Percent yield. Okay, now here's something else. Ooh, put this up. Okay, so one last thing for this video. It is impossible to really get, I mean, you might get over 100% yield on paper, but in real life, it's impossible, maybe because you made a math mistake or something, or some kind of mistake in the lab, but it's really impossible to get 100% yield. Okay, because no technique is 100% effective. Okay, so up here, when we talked about this stuff, okay, there's always going to be a molecule or two reactants that never meet each other. They don't bump into each other in order to make product. Okay, there's always going to be some of this left. Maybe that you can't detect it, depending on your well, even if you had the most expensive measuring device, you probably won't be able to detect one or two molecules. I know you won't. Okay, and then also it is the maximum product recovery. That's going to be impossible 100% because you might spill, might splash out of the container, and then not just that, but there are some reactions where it's really, sometimes the product turns around and does a backward reaction, and we end up getting reactants. So they make product and they go backwards. The reaction goes backwards and forwards. There's a lot of those reactions actually. Okay, so sometimes getting a 30% yield is good, depending on the type of reaction. Okay, but the point here that I'm trying to make, we'll learn about that later. That's when we get to equilibrium, if we ever do. But the thing is, it's impossible to get 100% yield. Okay, and if you get over 100% yield, then there was definitely something wrong. Something happened wrong. Okay, so I will cut this video shorter, cut it off now, and then we'll solve some problems in the next video. Some worksheet problems. All right, see ya.